Hello guys, we are live now.
Awesome. Hey everyone, this is Xibei from DoraHacks. Thank you all for joining us today for our Starship Use Cases Hackathon Round 1 demo day. Today we're glad to have three teams joining us to present their winning projects, including Helix by Elliot, Valhalla Space Hotel by Dennis and the Exodus Orbitals team, and Novel Satellite Constellation by IITK Rocketry and Space Exploration team. Congratulations to everyone. And before we kickstart the session, let me give you a quick introduction about who we are and what we've been working on to foster space innovation. So DoraHacks is a global hackathon organizer and developer incentive platform. We love to support innovation in blockchain, quantum computing, and space tech, and more. So we launched this Starship Use Cases Hackathon last October because we believe in the vast potential of space exploration offered by Starship's heavy lift capacity. And our team has designed 18 use cases and two open challenges for hackers to tackle. And we're currently working on optimizing and expanding the use case list. So through this hackathon, we like to motivate all space enthusiasts with engineering skills and entrepreneurial minds to build their solutions for space. And we just wrapped up round one, supporting four winning projects. We have three joining us today, and Nexus Aurora is the other team, and we will invite them when they are available very soon. And so round two is set to kick off on April 1st with a prize pool of $100,000. And we're aiming to support more space innovators in round two. And we're looking forward to see progress from our existing winning projects in round two as well. And furthermore, we have another ongoing long-term space resources and exploration mini grant program in place, through which we have supported 11 early stage projects so far. And our support recipients span a diverse range, including student groups, startups, researchers, and open source communities. So basically, everyone contributing to the space sector is welcome to participate and receive our support. So if you're interested in learning more, feel free to click the links below in the description. There you will find more details about the programs. We welcome you to join us, and we can't wait to see all your submissions and provide our support for your projects. And lastly, for the audience, during the demo session, feel free to share any questions you have in the YouTube chat room, and I will make sure to ask the teams at the end of their demo. Now, without further ado, I'm excited to pass the mic to the teams. So each team has 10 to 12 minutes for their demo. First, let's welcome Elliot to demo his project, Helix. Thanks so much for joining us today. Feel free to introduce a bit about yourself first before jumping into the demo.
Of course. I will go ahead and do that. Let me get this thing going first. Hello, everyone. My name is Elliot Ruzicka. I am an architect operating out of Manhattan, New York, USA. And it's my pleasure to talk about one of my projects today. This is Project Helix, related to the Starship use cases. So let me go ahead and operate this thing. All right. So quick outline about what I'd be talking about today. I'm going to talk about a little bit of the slight context for interplanetary human-rated interior design for Starship. The main idea that the project is all about, the scope of this project so far and where it's going, some key features that the project boasts, what I'm currently working on, and some next steps that I plan to work on soon, and finally wrap up with some milestones. So anyone can design an interior to a giant cylinder, and with Starship, it feels like almost everyone's had a go. There's one major assumption in all these Starship interior concepts, which is a sort of levels and ladders, or levels and stairs approach. In this paradigm, although it's functional on Earth, it exhibits significant inefficiencies due to the variable gravity environment. It's complicating astronaut movement, limiting space utilization, and reducing space circulation efficiency. And such a layout might also pose some avoidable safety hazards. And so I thought, at the beginning of this project, the main idea would be to combine axial and lateral circulation modes into a single, somewhat helical paradigm. And so this helical paradigm, it directly counters in many ways a lot of the challenges outlined in the above and for the previous legacy interior designs. It enhances the space efficiency to a degree, and also the adaptability in both planetary and microgravity environments. It increases space utilization and variety, and it also significantly enhances safety in typical operations as well as emergency scenarios. The scope of this project is a little bit twofold at this point. First is to validate the concept as a viable organizational framework via research, analysis, and critical review by the space community. And the next is to develop a preliminary design to a reasonable degree of detail that proves out the feasibility of the concept. So I've written about this project on my website, but briefly, some of the key features here are it's gravity agnostic organization. So meaning it can function both in microgravity en route to a planetary body like the moon or Mars. It has diverse configurable options. So depending on the mission profile, it can be reorganized such that it provides the needed spaces and none that are not required. It's non-linear. So this is something I could briefly mention, talk about linearity when it comes to the astronaut experience. Sometimes if they're in a space that is proportionally very long compared to its width, they can perceive that they're falling and be startled and disturbed. So being able to mitigate that is important to the astronaut experience, especially for people who might not have been trained formally as astronauts. Multiple circulation pathways. This is a major improvement in the way of safety and not necessarily exiting, but egressing to safe areas in the case of an emergency. And also in a similar way as the configuration options, a range of space sizes that are available depending, again, on the mission profile. As well as community spaces and privacy spaces, and not just private spaces. So a little bit of some of the work that I'm working on now. I am currently developing an optimization process for the dimensional parameters, so like different radiuses and heights and angles and everything. Using key metrics such as like the area efficiency, the slope of the helices as they go up, the travel distance to circulation space, and also addressability, how addressable are the usable spaces. Also working currently on developing support and utility layout concept that aims to minimize the interstitial plenum space. So integrating these spaces that are usually kept separate and take up a lot of space in a building's plenum can be integrated into a much smaller space, allowing less wasted space between occupiable zones. And I'm also currently developing options for the assembly scheme. So we'd have a central utility shaft, add-in support structure for the occupiable modules, adding in different sizes of modules, and leaving open spaces for the circulation pathways. And as these get added on, you can see that the circulation pathways rotate as they go up and around, which lends the project's namesake. So currently, the next steps that I'm planning on for this project are to develop the structural and utility concept, as I briefly mentioned a couple slides ago, focusing on the right sizing of the members and accounting for all the needed utility routing. Right now, the work is notional, and it should be verified against what is actually planned for long-term human transport missions. I also plan on creating a functional physical model to demonstrate these concepts. And this would be based on both the results of the optimization analysis as well as the more developed version of the structural and integrated structural and utility concept. And also, lastly, the next step would be to develop a paper for presentation at the 2024 International Astronautical Congress in Milan in October. I believe they extended the deadline for the abstracts, and I think today is the last day for those abstracts. But this is the one that I submitted to the conference. Hopefully it gets picked up and I can continue writing my research for this project. Next milestones for this project are, of course, round 2 funding from DoraHacks Hackathon. And next would be the presentation of this paper for the Congress in October. It feels like I kind of flew past this thing, but definitely be open to any questions that anybody might have about the project. And I could go back a few slides and talk about things. But if you'd like to know more about this project or my other work, you can go to my website, which is orbital.design, or email me at orion@orbitaldesign. With that, it's been an honor to have had the opportunity to demo my ongoing work to you and to all those watching online. Thank you.
Thank you so much, Elliot, for your demo and for sharing your next steps, which I am really looking forward to seeing the progress in round 2. While other audience or teams think about what questions they have, I do have a question, because
Sure.
I noticed on your website, orbital.design, you've put together a Q&A list for this project specifically. I'm wondering, what is the question that you were asked most often, or like criticized most often, and what is your response to that? And yeah, just share me a little bit more about the most asked questions for your project.
I'm glad you asked that, because this is actually not my last slide. I had prepared a couple more slides for this to kind of get to that. And that was actually, you're right, I posted a lot of my projects in my blog post to some of the space design communities on Reddit for comment. And one of the most common I got was about the saying that the helix corridors take up a lot of space and or are not useful. So we could continue on my slideshow. This is kind of what people think of as transportation corridors. In this case, transportation from one building location to another, city location to another, or perhaps as an interior comparison, this would be a transportation corridor, mostly used for functionally accessing different places but devoid of people and life. But I would also submit that these are examples of circulation corridors. These are not places that people are just using to drive around their bodies from place to place, but this is spaces that people actually occupy and use. And it's the same way that's intended with the helix paradigm. These openings that allow users to access different areas of the Starship are not just for circulation hallways. They're meant to be used as positive space. So just because they're connected to each other is what allows them to be used both as circulation and as positive space. So do I have anything else on that? Yeah, so like the corridor can be activated by the crew in a similar way to like a community market or a pedestrian street. So it's not merely a highway, but it's a usable space like any other. So thank you for the question.
Thank you for answering my question. I don't see any other questions from the live audience yet, but if you're looking at this video later on, if you have any questions, feel free to reach out to us at DoraHacks, or you can find more details on orbital.design alias website to find more details. And yeah, thank you so much. Next, let's move on to
Sure.
Valhalla Space Hotel by Dennis and the Exodus Orbitals team. Welcome.
Thank you. And let me try starting presenting the page we have. Share screen. Yes. So why space hotel and why artificial gravity? Our project is all about exploiting the capabilities that Starship has, and one of the key technologies that's currently absent from existing is artificial gravity. Artificial gravity using rotational acceleration is often discussed in science fiction, but so far we have no real hardware in space that have this capability. Why it is important? If we look at the solar system, there are no other places there that have the same level of gravity that Earth does, unless we take into account like planets like Neptune or Saturn, which currently pretty far away from being explored. If we ever build a Martian colony, we have to deal with the reality that the gravity is different on Mars. And gravity is a big factor in pretty much every everyday interaction of matter and energy. Planets, with specific gravity, have very specific structure in their geology. And if you look at the life forms, how they've been developed, the gravity defines many features of the living beings. And we know from the experiments in space that lack of gravity definitely makes an impact to the development of life. Now, so if we want to do the space exploration right, we want to test things before we try them. So if we are going to build a Martian colony, we would want some medical data on the Martian gravity in the long duration, in the long term. So that's why artificial gravity is one of the key features of our project. Now, Space Hotel itself is not a new idea. It allows basically short-term visitations for the people to space, and that's already being developed by a number of companies. That's why we want to combine the two and offer both the research and development capability and the recreation activities in space, which will be tremendously interesting for many people people to try. And also Starship allows the large-scale structures, large-scale space hotel, potentially bigger than International Space Station. This project, Valhalla, is our first take on the space station design, but not the first, first attempt at artificial gravity space station. There are a number of useful references in the literature, so we decided to try one of the common designs with the two rotating modules all over the common axis, and we picked the gravity within the specifications of the surface of Mars. That means we can test our assumptions. The idea is we will continue with development of the space hotel design, and we'll present that at the industry conference later this year at Space Tech Expo in Bremen. And we continue working on this design to improve it through the next round of DoraHacks Hackathon. And the long-term vision is actually attempt to get it funded and launch it. We, Exodus Orbitals, are working on the number of projects right now, but the long-term vision of our company is coded in our name. The Exodus Orbitals, meaning building space stations that will allow humanity to expand beyond the home planet. And getting the design right is one of the tasks we have. With Starship, it provides unique opportunity to build and launch such space stations and create any additional infrastructure elements with orbital tugs for assembly and in-orbit manufacturing facilities, which can be a next feature of our space hotel project. So it becomes more like a space settlement with facilities for both life support, entertainment, and manufacturing. That will allow more and more people to get into space and to start space settlement in its true nature. And of course, with Space Hotel, it's not all work. We listed a number of entertainment activities that you can do in space, some of them unique to the space environment. So the purpose of our project is threefold: to create an artificial gravity environment that will allow to gain knowledge about life on other planets, such as Mars, with different gravity level, to create a commercial project that would attract people to visit it and to enjoy experience in space, and to make it a foundation for the further design of the further construction and design of the bigger and larger space structures, with the intention of that becoming a new direction, another direction in space colonization, with a large amount of those orbital stations in orbit around Earth and later around other planets that can become an extension to human civilization in space. Thank you so much. Apologies for my voice. I'm a little bit damaged from all the effort, but happy to answer any questions.
Thank you, Dennis. Hope you get better soon. And I noticed that Bojan is here as well. Is there anything Bojan would like to add on to that?
I wanted to discuss a little bit about the space activities. As Dennis mentioned, we want our guests and our visitors to be entertained, so we designed a number of space activities, starting from spacewalks. Even we went further into designing activities even for children, such as doing arts and crafts in microgravity. And there is an idea about a swimming pool into space, which is still being considered and into development.
Got it. Thank you, Bojan. I noticed that Elliot asked a question. I'll share that with the live audience as well. So Elliot from Helix asked, are you familiar with the artificial gravity work of Theodore Howe? And if so, are you taking that work into account in your design? Dennis, if you can, please feel free to
Yes,
ask that
absolutely.
question.
Actually, there's already one reference to his work in the project page, but I read pretty much every paper when doing my master thesis at the university, and my project was an artificial gravity space station with a Martian gravity level. So you can imagine I know quite a lot of this about this work.
A
Yeah,
follow-up question, yeah, from Elliot. Would you agree that a rotating artificial gravity tech demonstrator would be a first step in this? And if so, what would you recommend for such an uncrewed demonstrator?
yes, absolutely. Yes, mechanical design that replicates the some of the kinematics and design of the bigger space station would be an excellent demo. I thought about that quite a lot. I was thinking about, say, 1 meter size satellite, the scale model of the space station that can be launched on on any of the existing rockets, and of course at much lower cost to verify at least the attitude control behaves. And the bigger one probably will have some life support elements to test and docking procedures. Eventually, there will be a full-scale prototype launched into that. But yes, absolutely, might try some smaller uncrewed demo first.
Got it. Thank you, Dennis, for answering. I have a question. Since there is no next steps shared in your presentation, I would like to ask, like, what is your roadmap for the next half year, or in other words, what can we expect in round 2?
Yes, I think I mentioned them briefly. So the immediate next step is to incorporate the feedback from the DoraHacks and prepare for the second round, improve the design, including the operational procedures, and make it a bit more polished. Then we will continue to work on that as one of our projects, potentially seeking funding for the development of the design in our company product roadmap, and present that at the industry conference at Space Tech Expo around November this year. I think that would be interesting for the audience there. It is time to look at what Starship is being capable of and look for the variable use cases.
Yeah, definitely. Because from our DoraHacks perspective, we believe that projects that are building on top of Starship's lift capacity are just fundamentally different from the other projects that are utilizing the current launch services. So yeah, thank you so much, Dennis and Bojan, for sharing. Let's move on to our last team today. Novel Satellite Constellation by IITK Rocketry and Space Exploration Team. Welcome, guys.
Thank you, Zibay. So we would like to start with introducing ourselves individually first. So I am Rangan. I am a second year undergraduate in IIT Kanpur in the Department of Aerospace Engineering.
Hi, I'm Gopika Shivani. I'm also second year undergraduate in aerospace engineering.
Hi, I'm Kashmira
Hello,
Kirti. I'm also
hello, I am
second year
Priya Gupta.
undergraduate in Space Department.
Hello, I am Priya Gupta. I am also second year undergraduate in the Department of Civil Engineering.
I would first like to say that we are a team here at IITK, and our primary aim was to develop model rockets and launch them and take part in global competitions like the Spaceport America Cup. I'm not sure how many of the people here are aware of it, but yeah. So that was pretty much our primary aim. But we were pretty excited to know about DoraHacks and this Starship use cases hackathon, and we really feel that such initiatives in the space sector is required to actually push people to innovate and take this deeper into this space field. So yeah, I think I'll present the short slides that we have prepared to let the audience know about our idea.
Sounds great. Thank you so much for your introduction.
So yeah.
So, our team has come up with an exciting idea of addressing the current increasing concern of the space debris. This project is a big step forward in making the space safer and more sustainable for everyone.
Okay, so let's discuss about our motivation to work on this project. So, as like my friend mentioned before, we all are relying on spacecrafts and all in this current world, right? But along with that, growing concern is the problem of space debris, right? So, our plan is to propose a solution for this problem, like the increasing concern of space debris, through our strategical model of novel satellite. So here, actually, we are planning to launch some chief satellites and service satellites into geo and LEO stationary orbits respectively, and hereby like we are planning to refuel and repairing the existing satellites in the orbits, and thus by like we can increase the operational lifetime of the existing satellites, right? So and along with that, another concern is like for repairing the satellites and all, we need constant efforts, right? It will cost a lot too. So to mitigate through the cost efficiency, like we are planning in orbital refueling and repairing, and thus we can effectively manage the cost and other concerns also. And along with this, we are also focusing on deorbiting the dysfunctional satellites, which in turn causes the problem of space debris. So for more technical details, my friend Ria will be joining.
So as Gopika said that to do the work, we have chief satellite and service satellites to do. So coming to the what is service satellites? So basically the work of service satellites is for refueling and servicing the existing satellites in the orbits like LEO and VLEO. So service satellites will be equipped with different docking and fueling mechanisms to achieve their purposes. So we also have included and implemented different mechanisms in our report. So what they will do, and also that the service satellites will clean up the space debris, because our aim is to clean the space debris. And also that we can implement this by exo-braking or drag sail system equipped in the different service satellites. So now coming with to the chief satellite. So like what they will do, they'll provide like a help to the service satellite. So they will be in the geo orbit. So they will enable, or like they will be exposed to maximum solar radiation power. So being accessible to by the service satellite at the same time, like at the same time they will be at the outer orbit, so they will be exposed to the solar radiations, and also with the what geo satellite what LEO satellites. So like our plan is to deploy such 4 satellites in the chief satellites, and we have come up with like analysis to deploy in a single launch.
So yeah, just to add a bit more about the functionality of the chief satellites, I would like to add that the chief satellites are actually will be much bigger in size, and as compared to the service satellites, and will be stationed in geo, as Ria rightly said. And so basically they will be the servicing and fueling stations for the service satellites, so that whenever the service satellites need repairing like basic repairing or refueling, they can perform a transfer from LEO to GEO and get refueled or serviced, and then again come back to LEO to service the existing satellites. So now that raises the requirement of an orbital transfer from LEO to GEO. So now for that we have done an analysis like what can be the most optimum way of transferring our service satellites to the GEO, and to actually have that the rendezvous with uh, the the chief satellites which will be there in the GEO for servicing them. So for that, there are various maneuvers known as Hoffman maneuvers, which we have analyzed, and like we have included that in our report, as there has to be a partial plane correction at the apogee and the perigee of the transfer orbit of the Hoffman transfer orbit, to save fuel for the transfer and make it efficient. Also taking into account the wait time for the injection into GEO and rendezvous. So that was about the orbital transfer. Next up, we have so coming to our future plans. So this project was we chose an open-ended problem because we thought that we already had this concept in mind like beforehand, and so we wanted to develop on that, and so that's why we chose this satellite constellation idea, and we would like to proceed with this as an open source project. Like already our build is available on the DoraHacks website, and also since at IITK we have a 9,000 plus strong student community, so we are hoping to engage like other students, and in fact even professors in the space department, so that we can work on this further, and like we will try to implement this during this summer, that is like around in April, May. And yeah, so that is one thing. So now what are the things to progress about, includes like the subsystem level design for the chief and the service satellites, because what all functionalities they have or we have proposed, that has to be catered by some mechanical design of the docking systems and the refueling systems that are existing currently, or maybe coming up with a new mechanism as such. So that is one thing. Then our cost analysis wasn't very rigorous, like we personally felt that, and so we'll try to study more on that and analyze the cost comparison between the orbital maneuvers and the and also take into account the cost analysis of the actual Starship launch, so that we can optimize the number of service satellites that can be launched with just one Starship. So that is second. Then another very interesting thing that we came up studying about while working on this idea was that of in-space manufacturing, which takes the advantage of microgravity manufacturing, which is actually very efficient. But yeah, so we also want to study more on that and explore that as a possibility if it can be achieved, using our service satellites. Like if we can have some in-space manufacturing within our service satellites, then that is one area that we need to study more on, and come up with that as an added use case or functionality, let's say. So yeah, that. And we also want to develop a simulation of the proposed concept of operations, like how the service satellites will be launched from the using the Starship to the VLEO and injected there, and what number of satellites will be launched in one go. Then how are the geo satellites going to be injected in, how are the chief satellites going to be injected in the geo as well. So that we want to like develop a simulation for that, maybe through some code, or like let's say a software, something like that. So we'll also try to develop a simulation on that. So yeah, these are pretty much our future plans, and that was all about what we had to present. We would love to know if there are any questions and for us.
Thanks so much, team. Great work, and the future plans looks pretty awesome. And we look forward to seeing your progress in summer. I hope it's going to be a very productive season. And apart from next steps, I'm wondering what is the hardest part so far in your project? Anyone wants to answer that? Like
The hardest part,
one
yeah,
of the most difficult challenges you faced, and how did you solve it?
I would say the most difficult challenge is to study about the existing mechanisms for docking and refueling that are there, and how exactly are they implemented. Reading upon that and getting enough information about that was a bit challenging for us, but we did came across some of the ideas that are actually have been proposed by various other commercial entities based in US or Europe, and we think that since they are also in a testing phase right now, so we would also want to personally come up with maybe a new novel mechanism as well for docking and refueling, so that that can be implemented in the service satellites that we are talking about here.
Got it. Thank you for elaborating on that. And I see that Elliot posted another question for you guys. I'm just gonna read it out for the audience as well. So the question is: as the risk posed by orbital debris is largely related to the mass and size of the item, what is the largest item your system would be able to deorbit? Would the SurfSats be able to deorbit large second stage rockets like Cosmos and Zenith? Also, would this SurfSat refueling system be backwards compatible or only available to satellites equipped for refueling? Any thoughts on that so far?
So yeah, to answer the first part of the question, I think there can be like two approaches. One is that we take into account the a considerable amount of dimensions for the South satellites, such that they can be used to deorbit large second stage rockets, or we can have an additional mechanism for like maybe let's say uh, kind of destroying maybe, or like what to say, um, yeah, destroying the second large rockets which are out of scope of deorbiting at once, so that they are like they split up into various components, and then you can target each component and deorbit them using the existing mechanism of exo brakes, or maybe attaching track sails to them. So yeah, that would be for the first part. And the second, I would want to like, what do you exactly mean by being backwards compatible? I'm not pretty clear on that. If you would like to.
Yeah, briefly, I understand that not all satellites are equipped to be refueled.
Yeah,
Is that
right.
not
So
so?
yeah. Okay, got it. So for the satellites which do not have a refueling mechanism like the existing satellites, all of them will not have, of course. So that is what I was talking about. That we need to develop, you know, a new novel refueling mechanism which would actually, not have that constraint that will actually be needed. That the existing satellites have some mechanism for being refueled. So yeah, that is a thing. So maybe by let's say by adding, let's say we can add some existing batteries maybe to extend the the lifespan by a shorter amount of time, maybe, if that's the need. So there can be various possibilities and like various approaches for that. So yeah.
Sounds good. Thank you, team. Yeah, I don't see other questions coming in from the audience. And if anyone else has any questions, feel free to click the link in the description. You can find more details on the each project's page, and there you can find their website or their socials. You can get in touch and ask them any questions you have later on. So yeah, just thank you all for joining us today, for presenting your project. We look forward to seeing all your progress in round 2, and hopefully we could provide further support. And before we wrap up, I want to quickly highlight again that the submission portal for our Starship Use Cases Hackathon round 2 is set to open on April 1st. So all you guys are already in because you participated in round 1 already, and we're gonna keep following up with your progress. But for new joiners, just set the reminder. Feel free to join us on April 1st. We welcome you to join us, and we look forward to seeing your submissions. We have prepared a prize pool of $100,000 and designed 18 use cases and 2 open challenges for you to tackle. We also have our Starship. Space resources and exploration mini grant program in place to support everyone contributing to the space sector for the long term. The submission portal is open all year round, so we welcome everyone who has a passion for space to join us and shape the future of space exploration. If you want to learn more about us and our initiatives, please feel free to click the links below in the description to our grant and hackathon pages. With that being said, just one more time, huge thank you to all the teams. I really appreciate your time. And thank you to all the audience for tuning in today. We do have more space-related live sessions and contents prepared for you. So make sure to follow us on YouTube or Twitter at DoraHacks so that you won't miss out on any updates. And that concludes this demo day featuring all 3 awesome winning projects in our Starship Use Cases Hackathon Round 1. So thanks so much, everybody. We will see you soon. Have a good one. Bye.